All right. Hello, all. Welcome to the obo-academy. Thanks for attending today's presentation. I'm Harry Caulfield, and our speaker for today is Anita Karen, who is a semantic web developer with the EMBL API. Anita has been there for about 2.5 years now, I believe. But in that time, she's been very productive in developing tools for doing ontology validation, including as part of the HubMap project, as well as contributions to relation ontology, Uberon, and numerous other resources, all in our great OBO ecosystem. But today she will be presenting on what I feel is one of those crucial topics in ontology use and development, and that's ontology metadata standardization. So with that, I believe we have whoever is going to pick it up first, since we have some slides there, Nico, but we'll go ahead and take it away.
All right, yeah, so let's do everything through your slide decks, Anita. So just move on to the first slide if you like. All right, so just to set a little bit the scene for today. So many of you have heard us all talk about this subject many different times, but I just feel like it's always good for setting the context a little bit about the kind of magnitude of the effort and why we do need standardization and validation so dearly in our community. So the mission of our, let's say, community is to build a basically web of interconnected knowledge that covers a lot of different data from domains like diseases, chemicals, anatomy, assays, information, content entities, and so on. And that just to make this like the magnitude of this problem super clear, we have not only very dispersed communities, but we have like extremely different and difficult pieces of knowledge that need to be represented and interrelated in order to achieve something that looks even remotely like an integrated knowledge graph. We call, let's say, this has not been very widely publicized, but we call this idea of a huge interconnected, integrated ontology in the OBO mission, the Grand Unified Ontology of Biological and Biomedical Knowledge. And the goal here is really to stick all these different pieces together that are developed in a decentralized manner into one coherent piece. Next slide, please. So in order to be able to solve such a problem, we need to kind of dig our way through many different layers of interoperability. So at the bottom layer, we have simply the necessity to have the information that we want to integrate openly available. It needs to be findable. It needs to be accessible, some basic, let's say, fairness. On the next layer, we need to consolidate our formats and our tools. So for example, the way that the OBO Foundry, that there was a long-standing battle consolidated was to make sure that everyone that releases their ontology has to release it in RDF XML format. And as if you're working a lot with these formats, you know that this is by far not the ideal format for all use cases, but the fact that we can expect every single ontology to be released in a single for sure in that single file format, which is well specified, allows us to build an ecosystem of tools like Robot, ODK, RDFlib, FastLib, many different tools that allows to process these formats and do something with that, which is a real great prerequisite of us of being creating an interoperable ecosystem. And now at the next layer, and this is where we are going slowly more into the subject of today, we have the layer of shared vocabularies and upper level integration. So shared vocabularies means, for example, if you want to define the relationship part of in your ontology, you want to make sure that this is exactly the same relationship as from the ontology next door. So we all want to be using the same predicates for defining the relationships in our ontologies across this grand unified OBO ontology. And the same, of course, is true for ontology metadata. When we want to define a synonym, we need to be able to use the same ontology. We have the obo metadata ontology for specifying which kinds of annotation properties, we call them, for ontologies we should be using. And the same is the core ontology of biology and biomedicine, which is COB, that provides an upper layer for a very high level upper layer for classes like for example, assay, material entity, and so on. And then at the very highest top, we have shared design patterns. And here, I just want to I used to, when I presented this, I kind of mostly refer to design patterns in the sense of like logical design patterns. But in fact, the design patterns are really all kinds of representation patterns, including, yes, the logical ones. So how can I define a disease in terms of an infectious agent? Or how can I describe partonomy in an anatomy ontology on the one side? But also metadata patterns like how do you, for example, record an abbreviation as a synonym? You could have one pattern would be to have a predicate as abbreviation, but in OBO we use a different pattern, which is has exact synonym, and that exact synonym has as a type abbreviation. So these kinds of pattern. So next slide. So for this is just like to really hammer home the difficulty that we are facing, and we are making a really big, we're building a real socio-economic, socio-technological system to deal with this by from the situation that we have all these like different like levels, different groups that develop pieces of this huge interrelated web of knowledge. And not only are these groups separated by locality in different countries, in different, completely different circumstances, but also by expertise. In some groups, maybe you have a lot of like technical expertise. In other groups, you don't have any technical expertise or at all. So how do you manage to encourage and get interoperability the way that we need across such a diverse set of groups? That is the problem that we are trying to solve. Next slide, please. So that is kind of like the point in which I will slowly lead over to Anita. So basically the question is when you make an edit to an ontology, how can I make sure that this edit is in line with all of these lots of very fragile interoperability concerns that I have just hinted at before with the pyramid? How can I make sure that the logical definitions look correct? How can I make sure that I use the correct annotation properties to describe who is the creator and the contributor so that all of these interoperability concerns are met? And next slide, please. And the way that we implement this, basically, the way that we enforce this is through continuous integration testing, which applies various different validation strategies of the content that we are pushing into the ontologies. You all know this kind of workflow. You make an edit, make a pull request, then you have some magic system in the background running validators of different kinds and then telling you, look, you made this and that mistake. And this is really what makes decentralized ontology development at all scalable across such a diverse community. And we have very different sorts of checks from our API checking, robot reports, custom Sparkle, and many more. And this is what I'm looking forward to hearing Anita share a bit of experiences on in the following. So thanks for your attention. And please, when we are moving over now to Anita, jot down some notes. And I hope really that we can be slightly bit more engaged also from the audience side in these obo-academy sessions. And, write down your questions, don't be shy, and we will address your questions in the end of this tutorial. So Anita, if you want to take it away from here.
Thank you, Nico. So after this great introduction, I have one question for you all. If you have an idea how many new terms were created in 2023 by the obo ontologies. I mean, yeah, the obo ontologies, it's the one that is available in obo-graph. It's only 39, but we know that obo ontology has more than 200. So yeah, it's still a small sample. Yeah, we can say that here, just to have an idea. So yeah, I went to the Sparkle query and using the obo-graph endpoint, and just simple like this let's start with the perfect world. And then I want to know what is I just filter here the terms that was created in between 1st January and 31st December, and I just want to know the label and then the contributor, if it, yeah, and then this would be the perfect world, because I don't believe all the 39 ontologies created only 940 terms, and actually only 7 ontologies created that I could find in Ubergraph now. All the Sparkle queries that I'm sharing here, you can access here later, and and then you can check yourself and then make another queries also. So this would be really the perfect world. Simple. It should be like simple like that. Just I want to know the label, the contributor, the date, and then I would know the exact number of new terms. But we know this is not a reality, so I thought, okay, maybe I need to add the two other annotation that we know that it's really it was really used in the best, that it's from the obo in owl. So it's the creation date to get the date, and the created by to get the contributor. So I just added these two annotations, and then I already get some more terms and a new ontology that only use these two new annotations. So simply with simply adding an annotation, we can have more results. But we know that it's not only these two annotations that we have seen in the obo world. We also have the DC date and the DC contributor. That is also a really a namespace used for a long time. So it's I understand they still use this, but even the DC terms namespace group, they also have already a notes there that they prefer to use the DC term instead of DC. So this is something that we can keep in mind. So so I was thinking, is it the number? Is it finished, this number 1,100? I don't think. At least we had more ontologies in the result, but I'm not sure if it's enough. I mean, there is still another annotations that are to represent the contributor. For example, the DC terms. And then we have, what I found in the results is that they clearly make a distinction between the creator and the contributor for the same term. So if the person created the term, it's used the DC terms creator. Otherwise, if there is another person, it adds the DC terms contributor. But in the end, is it us all contributor of the ontology of the term? So it's also another thing to think about. We know they are also creator and contributor. Do we need to make this distinction between the two annotations? So we see clearly that I think there is one especially one ontology that which use more the DC terms creator to represent the contributor. So we have increased a lot the number of terms. But it's not the end. we also have the DC creator, the same thing as before, the DC term, and then DC terms contributor, DC terms DC contributor, etc. So it's still it's still using this DC creator to have the, so we have again more terms included in the results, but it's not. Yeah, I keep adding. We could add as many as annotations here, and then I think we can always find a new term that use this annotation. Or yeah, and then yeah, maybe here I will finish here. Otherwise, I could stay here the whole tutorial. But then for the last one is the term editor that is from the IAO. That is, yeah, it's something also previously, and it was really used before. And then in the end, we have almost 2,000. If we compare to the first slide that the first Sparkle query that I share, it's almost the double. Yeah, it's more than double the terms that we could find, adding all these 6 annotations here for to get the contributor. So yeah, to have an idea here about the usage for each annotation, we see clearly that DC terms is still, it's good news actually, is still the majority of the annotation used. So that's good news. But we see that still have many DC date, especially, and not that many for the creator or contributor. And actually, I didn't include the query, but after I found out there is a obo-in-ao contributor, and then it's still for usage. That is, I'm not sure. Yeah, someone's using this annotation that is not really common everywhere. So if we could really standardize these annotations, we could have a clear sense for a clear answer for my question in the beginning. So just to summarize, how many new terms were created in 2023, and then these are all correct answers. Actually, we could say 1966 terms if we get the contributors. We could say 24, 27 if we don't get the contributors, only filter by the date, or even 3154 if we include the date as a string, because I restricted here exactly the date as a date time. So this is another thing to think. And then we have really many more terms if we include the date as a string, and many more ontologies. But also we need to think about all the X terms that there isn't a date of creation, and because no one added the date, but it was clearly a new term that we were created in 2023. Plus also there are W terms that use another date or contributed that I couldn't think here. That was the only annotation that I could think, and then I'm not sure if there are many others. But it could have their own, each ontology could use its own annotation for date contributor. So I think this could, I hope this it will make clear that the importance to standardize our metadata. So yeah, and then I just talk about two annotations. There's the date and contributor, but we have, yeah, I just put 20 annotations there, but we know that we have hundreds of annotations. And another example is the GitHub issue tickets. That this is all the list that I could, the list of annotations that I could find any reference to a GitHub issue. So they are really arranged, really many annotations if we want to find an information or something. And also the another issue or common problem is the values of each annotations. For example, for the contributor, I could find just some initials, the name of the person, the ORCID that is now we really would like that all ontologies could use. But again, also here, all the values here could be RI, string, or any URI. So we have really difference there. So yeah, to summarize all the messages here, we would like to actually if we ask gently to use the DC terms namespace instead of the obo and owl for the provenance, especially the date, the creation date, and then the created by, especially then. But then every annotation that also has one that has exactly the same in DC terms, we would prefer to use the DC terms instead of the OYO. That we try to deprecate it all this kind of annotation. And also the same case between the DC terms and the DC. So we, as I mentioned before, even the people who create the DC terms emphasize that they prefer that everyone use the DC terms instead of DC. So that's, and then what I said about the value for the contributor, use the DC terms and the ORCID. So yeah, and then for date, use DC terms date, and with the date time type. That's also important. So then could formalize, and then we could also use the search really related to date. For example, we could just search for month, for year, only months, and so. And yeah, for the synonym types, please use the OMO terms. We have here now a list of the all, because we used to Newbron, for example, they had its own synonym type, and then now we are moving all to use the OMO terms. And then these, I think I need, I just added to publicly say this, that actually they all both depicted by never existed in the namespace, the fourth namespace. The real one that everyone should use is the fourth depiction. So yeah, we kind of shocked when we find out this. And then yeah, I just joined the moment to say that. So yeah, so we have many annotations, and then how we would ensure that that we use the same metadata. We could never possibly check manually, go annotation by annotation, check all the values. We could never do this. So we have three tools, three different ways to validate in ODK. So we have a tool for different use case, and then I will explain quickly how each of these works. So the robot report we know very well. And then the custom Sparkle queries is something only available in ODK. And then there is also the oak validation that oak it's already available in ODK, but we can facilitate the way to validate your ontology. I will explain a bit more later. So yeah, the robot report, we know that there are 31 predefined Sparkle queries. They with general validation. For example, they verify duplicated annotation, the duplicated in the value. So the labels for the definitions and between label and synonym, etc. So the robot report also check for errors in misused obsolete terms. So for example, the obsolete class reference, obsolete property reference, it means that when a term is using, has an axiom that it's from obsolete class or obsolete property, it gives you the error. So also the errors in the obsolete label, it means that when the class or property is not there isn't the label didn't start with the obsolete, that we must add. Also the replaced by that, and then also checking the duplicated annotation, not Boolean, that it's also important because we all know that we need to add this duplicated annotation to that is true when we want to say the term is obsolete, and then if it's not a Boolean, the type Boolean, so it gets an error. There are also some general formatting validation, for example, the lowercase, white space, label formatting, etc. So here in the left is a sample of the using CL. I just got some. I picked some errors from the CL now, just to show some examples. For example, missing obsolete label. This, for example, as I said, if the class is obsolete, but the label doesn't start with obsolete, so it raised here it's a 1, only a 1. But then there is also the lowercase definition. For example, this A here should be uppercase. And then some missing subclass, some terms that isn't a subclass of. And then here is how you can add this to ODK. In your ODK YAML file, you just add this block of code here in the end of the file. So then we will add this robot report will be added in the test. And then you can choose to fail on error, or you can lower this fail on warn. And also you can custom profile, for example, that I will explain now. Because with robot report, you can also customize your profile. the profile is the 31 predefined Sparkle queries. So you can add other queries that must following the standard, the return the results like in a entity, property, and value. And then you can just add the path to the Sparkle query, like here in the profile text file. And then also in this profile text, you can change the log level of any of the previous queries that are defined here. And then to use this to use the custom profile in OTK, you simply use change the value here to true in the custom profile. There is a tutorial, a really detailed tutorial that I did last year. Here you can click here in the link to go to OBOOK. So the other way to validate your data or annotations, your ontology in general, is to use the custom Sparkle queries. Violation, we call it violation here. And this is part of this is inside the block of the robo report. So we just added a new key here inside the robo report, the custom Sparkle checks. So we list here each violation. Well, yeah, it depends on it's all customized. So yeah, it must have the violation name to make it work well. And then, for example, you can simply add a verification for to make sure that all the database cross reference that it's starting with it's all the, if you check that the annotation that it's the value is PMIG is exactly has dbxref. Otherwise, it will get it will return a value, and then the violation is met. So yeah, and then to easily use the Sparkle query, you can first you need to update the repository, so then we can add this custom Sparkle query to the make file, and then to see the results of the violation, you just run the make Sparkle test. I also, there is also tutorial in OBOOK that if you have some questions, you can check there. So then we arrive at the OAK validate. So the ontology access kit OAK, it's a Python library for ontology operations that it's, as I said, in OTK. So the OAK validate is one of these ontology operations, and then it used only now, right now, it can only use the SQL ontology version. So we need to convert to the AL file to DB and then we can use another tool for this. And then also, so the OAK validate command, it needs also a linkml schema to define the data model with all the constraints on the ontology annotations. So so right now we can run this command here if we have the DB, the version, the ontology in SQL. we can run this, and we can already use the oak validate. But then we will add some configuration to the ODK YAML file, and then you will be able to run this validation as part of the test in the QC. And also, if you want to run it locally, you would just use the make oak validate. So yeah, what is the ontology metadata model that is actually available there now? That's the default for the oak validate command. So I just picked here some of the information because the metadata is really complex, and then there is information about every and each part of the ontology, and also it gets you can check here in the link. You can check the entire file. So I just picked some of that is more related to the annotation here that we are talking. So for example, the linkml file looks like an ontology. But then it's more wordy. But we can have the class definitions, and then we can express it like an instance of the other class that we just defined. For example, we define the annotation property mixing, and then we just define another class that's called has minimal metadata, and then we say that it's annotation property mixing, and then we add the slots here, like the label and the definitions. And then after we all define all the classes, we define the slots that I will show you after that. So we here in this ontology metadata model, we have these classes, the has provenance, that we can just better organize our annotations. So the provenance we have created by, creation date, contributed, creator, created, term tracker item, all the annotation that I talked before. And then also for example, the has user information comment, that is the slots comment. See also depicted by and depiction. So I wanted to, and then I wanted to show that, for example, we said, I will show later, that created by and creation date, it's deprecated in this data model, in this metadata. But we need to specify all and each of the annotations, so then it count. So it's defined, and then it will get the result in case someone used these annotations there. So it will get in the results, it is duplicated, and etc. I will show also later. So so as you see here, because we can only use actually depiction now, but we need to define the depicted by, and then say that depicted by is duplicated and replaced by depiction. So that the metadata is defining everything and all details. So here is just to show more classes. We have this named object that is anything with IRI. And then, for example, the term here, that is, it can be, it's a name thing, and then it can be a class or a property, but not ontology. So it's defined, that is, they have all these 4 classes here. And then also they has life cycle that I will show later. And then also we see the class. Just showing some examples here. Not really just to show how it's defined in the schema. Yeah, for example, here in a class called class, that is a term. We define the label as required and the definition as recommended. And then we can also have a subclass of, which is a class. So because the class is a term and the term has all these subclasses, it's a mixing, the term is a combination of all these classes here, that we could say that. And then for the class, we say that we have the minimal metadata. So it gets the label and definition from this as minimal metadata. So this is how, yeah, just to give you an idea. So here are the slot definitions. So again, we have the label. That is, yeah, we know that it's RDFS label. The range, we can, yeah, for each slot, we define the range. And then the label type. And then, yeah, definition. It's not multi-valued, not the label and neither the definition. So for the comment, it's set true here, but yeah, there is a comment that's in obo format. A term cannot have more than one comment. So yeah, and then yeah, so here, as I said, depicted by, we just say that deprecated, and then duplicate element has exact replacement depiction, and then you have here the slot definition for the depiction. And then we are using the depiction, and then it's multi-valued, and the range it's image. So here also the term tracked item, that is yeah, using the IOO namespace, and then it's a name object, that it's it's a II here in this case. And then it also can be multi-valued. Yeah, and then here about the contributor and then creation date, I just put here together so we can check together. For the contributor, we can define a pattern for to check, so they also can check if the value for the GC terms contributor is only use OR like this. We could, yeah, I didn't add here, but then we can have more than one pattern, just adding the OR here in the regex. So I also added the GitHub group and ROR, but I just for the presentation, I just put the archive. So yeah, again, we can just say that it's duplicated, that we should use the yeah, we should actually, sorry, we should use the contributor here instead of the create. And then yes, the same for the date. So yeah, we saw here in the range of the label is the label type. So we can also define types. And then here we see that a label type is actually a type of tidy string. And then we see on top that a type string is, it's a string, and then you have a pattern, like it should not have a white space in the beginning and end. And then also the narrative text is, yeah, it's just another name for string here in this case.
Anita, can I ask something about this? If do you know if I were to define a pattern now, let's say we have tidy string as the base type for label type, and now we also want another rule, like for example, the string should start with an uppercase letter. Could I define another pattern slot on the label type that would also be checked, or would this override the pattern on the tidy string?
I think so. I'm not sure. But if they are not conflicting, if you are just adding, I can't confirm.
Thanks.
So after we check the metadata, so we just need to run the oak validate. Oh no, sorry. There is still one piece of the metadata model. It's the life cycle. Actually, I found this really interesting, but I couldn't see this yet working in the results of the oak validate. So I just found this interesting, and then I wanted to actually show this. We could actually create rules for a class that we have some slots there. So for example, in the first rule here, if a term is deprecated, it should have either considered or replaced by. So we have the preconditions, and then the slot conditions, that is the deprecated. So we have defined the deprecated as a Boolean, and then we just check if the deprecated equals true, this is the precondition. And then if a term is deprecated after, we need to check if any of these two slots here are available in the term. So if we have the term replaced by, so it should be required, or the consider slot. So another rule here is to check if it's if the class is not deprecated, none of. So we check here the none of the deprecated. So none of term replaced by, or the consider, or even the label should start. With obsolete, and then none of these should be in the class. And then the other is just to check the label itself. So just to check if the label is starting with obsolete. So this really would help a lot. And then, but now we have the robo report, which it doesn't include these two rules here to enforce to have consider or term replaced by, but at least it check for the obsolete label. So so as I said, for the report result, there are 6 types. So depending on the result of the annotation, we could have this 6 types. So for example, the min count constraint component, it means it's related to the required or recommended slots. The max count constraint component, it means if a slot say that it's not multi-valued, and then in the ontology we found there is more than one value. The deprecated property component, you said that we saw before, is for the obsolete slots. So every annotation that we say that's obsolete, and then in the annotation, in the ontology, we use this annotation, so we'll get this type of the error. So we also have the data type constraint component, that it's only checked for the type, but then in the moment it's only checking for a string or RI. And another one is the pattern constraint component, that is just to check for the pattern that we defined before. And then the closed constraint component, that is any annotation that was not actually defined in any slot. So I'll show you. Here's an example. I use the CL as an example. So as here you see the min count constraint component. For example, here it's missing the definition because it's recommended. We define it in the metadata. So here we have also created by two CL terms using the deprecated created by. And here I just added this. Yeah, it's not the, this is not a, in the moment, it's not the problem in CL. I just added another label for this term just to see this error here. So we can check when we define the label as not multivalued, and then in the ontology they have more than one, so we see the error here. So here the data type, for example, here the comment, there is in this term there is a comment that is not a string that we should investigate. And then also is here there are some false depiction that are not actually RI that we have defined in the metadata. Here in this term, the GC terms contributor is violating the pattern. So I have checked this, and sometimes it can be just the type. If the archive it's actually a string instead of RI, this also has this error here of the pattern violation. And then of course, if the URL is not exactly match the pattern, so and then as I said, for the date, for the data type, it cannot actually verify that is a date time or any other data type. So it says that it's wrong, but because it's date time, but it's just the limitation of validate. And then here an example of the closed constraint is the DC date that it's not defined in the metadata, so it can't find any of this in the metadata, so it get the closed constraint. So here after you run the command, you also you know that it's finished when you see this summary. It says the number of violations or the errors by the type and the annotation. So it's a good summary to have an idea. But it's related to the whole ontology, so it can have it's also included the annotation from other ontologies. It's almost so as I said, there are some limitations, and the most, I think, the more limited thing is that we cannot actually test for other data type. It's only IRI or literal string. So the report also is not, we cannot at the moment filter, or it only gives the result from the from the ontology, it gets the terms from all the imported terms. And then, yeah, as I said, also the stats, the number of annotation by report type, it's also including all terms. So, and then another thing is the closed world by default. Sometimes if you want to define different metadata schema, and then, for example, only one for obo profile and then other for ontology to have more specific for your ontology, you can't, no, because it will be conflicting if you don't define a slot in the schema and then in another, yeah. So yeah, to finish, so yeah, these are the comparison between the three tools. So yeah, the custom Sparkle query, it's good to check for checking the literal data now. And then we can also use to really complex validation as in you want any complex validation. And then also it's good to check for before implementation or before including or request some including to robo report or they'll validate. The robo report is good for, yeah, as I said about the obsolete case, the Mizu's on obsolete case, that it's now not really available in Yolk. And then also the duplicated case. Yeah, so Oak, it's...
Anita, can I just jump in, sorry, real quick, so that we get at least one question shot out before the end of the meeting. Is this the last slide, or do you want to say something else after that?
I just have a question, but then, yeah. No, yeah, this is the last one.
Okay, so let's first of all say thank you. This was absolutely awesome. I really learned something today, and that says something after all these years. Sabrina, do you want to shoot out a question here for Anita to finish up?
Very quickly, first of all, thank you. It's very obvious something needs to be done. And so thank you so much. And having the validations are great. My question, there's a lot of questions, so we can follow up on site, but where can I find what all the rules are? And maybe you already said, maybe it's in the ontology metadata model, but also how is that decided, and how is that, who decides, how is it decided what the best way to do it, and how is it communicated to everybody who has an ontology? I know, big question.
Yes, it is that I'm not I'm not sure if I am the best person to answer that question, but then I would say the obo foundry, it's the most, the best place to ask this kind of question. And then there is a lot of in the obo foundry site, the website, but yeah, that's hard to really, I can't, but then we could discuss this in the, you could always open discussion for in the obo Slack, and then say, oh, I don't really agree with the choice of the annotation and etc. Yeah, but then always open to discussion.
Yeah, I think the biggest thing from my perspective is to make sure that everybody is aware that this is happening, and for example, like using DC terms versus the OIO, is there a is it just a preference, or is there something more behind one being better than the other? Or is it just everybody, the majority uses one, therefore let's go with that one?
I think the DC terms, it's more official than the obo in our prefix, because it's only from the obo world. The obo in our prefix is something created inside here between us, but the DC terms is something everywhere. It's globally known, and then they have exactly the annotations we use. So I think that's the move, at least from this obo-in prefix annotations, yeah, or namespace.
All right. Unfortunately, it looks like that's about all the time that we have for this session, but you are certainly welcome to continue the conversation on Slack. So thanks everyone for joining, and thanks for Anita for our talk today. And
Thank
yeah,
you.
Thank
next
you.
Obo Academy.
Thank you. Thanks so
Thank
much.
you.